Good afternoon, my dear students. How are you? Welcome to one more fabulous session from Infinity Lane. I am Suresh, Faculty of Chemistry from Infinity Lane, Bryce Chaitanya. How are you all, my dear students? Hi, Annamani. Hi, Richa Sharma. Good afternoon. How are you doing? So, am I audible? Am I audible? And am I visible? Please give a confirmation in the chat box, my dear students. Great to see. Good gathering, right? वेरी गुड. सो आज का सेशन है स्ट्रक्चर ऑफ एटम. ये प्रीवियस सेक्शन का कंटिन्यूशन है. सो आज हम पढ़ाने वाला है क्वांटम मैकेनिकल मॉडल ऑफ एटम, है ना. सो स्टूडेंट्स, कुछ आवाज का कुछ प्रॉब्लम है क्या? देखो, राइट. एम आई ऑडिबल? जस्ट गिव अ कंफर्मेशन इन चैट बॉक्स, माय डियर स्टूडेंट्स. यस, गुड आफ्टरनून. अंडरस्टैंडिंग थिंग्स. आपका शुभ नाम क्या बेटा? सो रिचा शर्मा. यस, होप यू ऑल कैन सी मी एंड कैन हियर मी. गिव मी एक थम्स अप एंड फायर इमोजी भी देना है. आदित्य चौराशिया, कैसे है बेटा? राइट. अननोन, आई एम फाइन, थैंक यू. आई थिंक यू आर अभिनव, एम आई राइट? योर नेम never you change your name, na? Right, that's good, sir. So many unknown names are there. If you keep simply saying unknown, so मेरे को पहचान है. So अभिनव, I know. याद है, प्यारा बच्चे के लिए मैं कैसे भूल जाऊंगा बेटा. आदित्य चौरासिया. So I'm fine, thank you बेटा. आदित्य, right, fine. So welcome to NEET STEP UP 2025 program. In this NEET 2025 program, as for formalities, I am just deciding one more time, we are conducting NEET classes for free of cost, physics, chemistry and biology, right from 12 o'clock to evening 6 o'clock. So these lessons are taken by your eminent professors, and I am Suresh Sir, Faculty of Chemistry. So we are going to take these sessions at the level of NEET. So every day without fail, you please join these sessions and make use of it. And आपको कुछ डाउट होगा, सर यूट्यूब में ऐसे क्लासेस अटेंड करने तो नीट निकलेगा नहीं निकलेगा? आप बिल्कुल निकलेगा बेटा. सो अनडाउटेडली विदाउट एनी हेजिटेशन आई कैन से दैट, है ना. हाय इशिता, निर्मला जैन, हेलो. सो one more important thing, these professors in Infinity Learn, we are giving the content in such a way that you not only clear NEET, also you can be a topper in it. But एक दिन देना है, so हर दिन आप आना है. So work sincerely, follow the guidelines given by the teachers, and you just subscribe to the channel and एक बार like मारो and share with your friends. And also you given description link में एक telegram channel दिया हुआ. So in that if you just join in it, you will be getting an updates classes के बारे में, NEET के बारे में, कैसा होगा, क्या update क्या आते. So सभी आपको मिल जाएगा बेटा. So what not, we can start the session. We can have a very good fabulous session right now. Are you all ready with that? एक बार fire emoji thumbs up डालो so that we can start without any delay, my dear students. So सब ठीक है? Okay, we are entering into the monsoon slowly. So गर्मा गर्म. So the weather is changed to थोड़ा सा ठंडा, है ना. And interesting classes भी है हमारे पास, है ना. Right, that's good, fine. So आज हम चर्चा करने वाले हैं क्वांटम मैकेनिकल मॉडल ऑफ एटम. फिलहाल हम क्या किया गया? So you learned about fundamental particles and Rutherford model and the nature of light and hydrogen spectrum, Lyman, Balmer, Paschen, Brackett, fund these spectral series का एक बार analysis भी किया. So wavelength भी calculate किया, frequency भी calculate किया, spectral lines number भी देख लिया, है ना. एंड बाद में एक्सटेंसिव डिस्कशन अबाउट बोर्स एटॉमिक मॉडल कर चुका, है ना. एंड अगर आपको कुछ क्वेश्चन मिलेगा तो ये फिलहाल जो टॉपिक्स चर्चा किया गया उसमें बोर्स एटॉमिक मॉडल से आपका ज़्यादा से ज़्यादा क्वेश्चंस आने का संभावना है बेटा. सो दैट ख्याल में रखो बोर्स एटॉमिक मॉडल, आपको फिजिक्स में भी फायदा उठना की कोशिश करो. सो इट इज अ कॉमन टॉपिक फॉर द फिजिक्स एज वेल एज इन केमिस्ट्री बेटा, राइट. सो डोंट स्टॉप योर चैट बॉक्स, कीप यूज दिस चैट बॉक्स फॉर आस्किंग डाउट्स, है ना. So that chat box, this is not a radio session, okay, this session is a live session, two-way interactive session. I am teaching you guys, continuously interact with me and get use of the doubts as well. Any interactive doubt that is related to the current topic is going to be valued and it is going to be discussed. No worries, that's great to see. Nice emojis Ishita. So राइट. सो आज क्या चर्चा करने वाला है, और एक बार हम बोर्स एटॉमिक मॉडल का थोड़ा सा रिकैप करने का कोशिश करता हूं, क्योंकि ये बोर्स एटॉमिक थोड़ा ज्यादा इंपॉर्टेंट है. ये नीट एग्जामिनेशन में ये टोटल एटॉमिक स्ट्रक्चर से कम एक क्वेश्चन रिजर्व्ड है. सो अगर मिलेगा तो 2 क्वेश्चन भी मिल सकते हैं, राइट. सो we can see one more, de Broglie hypothesis, dual behavior of the matter भी एक बार, and we can see Heisenberg uncertainty principle and Schrodinger wave equation and orbital shapes. फिर भी आपका इलेक्ट्रॉनिक कॉन्फ़िगरेशन, एंड उसमें आपका आ जाएगा क्वांटम नंबर्स. एक क्वांटम नंबर से definitely you will get a question. If you get a question, so the topic is going to be quantum numbers, if not Bohr's atomic model. ठीक है. सो टोटल डी ब्रोई हाइपोथेसिस से पूरा के पूरा क्वांटम मैकेनिकल मॉडल आ जाएगा. सो व्हाट नॉट, वी कैन जस्ट लीव एवरीथिंग एंड वी जस्ट फोकस ऑन द कॉन्सेप्ट इन टुडेस क्लास, समझे. सो एक बार बोर्स एटॉमिक मॉडल देखना. अकॉर्डिंग टू बोर, इलेक्ट्रॉन रिवॉल्व अराउंड द न्यूक्लियस इन कॉन्सेंट्रिक सर्कुलर पाथ. सो these circular paths are given as like this, okay, right. So this is your nucleus, electron is revolving K shell, L shell, M shell, N shell. So if an electron revolve around the nucleus in a concentric circular path, इसका जो angular momentum जो है ना, that is mvr is equal to nh by 2 pi. N is the shell number, it is an integer, n value is going to be 1 2 3 4 initial. Each stationary orbit do have energy. So electron, as long as it revolves in a particular shell, it neither loses or gains energy. So they are called stationary shells. So everything is being discussed. A quick recapture, जल्दी से जल्दी कुछ करना है ना बेटा, बिकॉज आगे ज्यादा कंटेंट भी है. So that I just want to say that, so if an electron revolve in a particular shell, इसका एनर्जी हमेशा कांस्टेंट होगा. सो दैट इसका रेडियस भी कांस्टेंट होता है ना. लेकिन एक चीज है, इलेक्ट्रॉन का कुछ हॉबी है. सो जब आप एनर्जी दे सकते हैं ना, ये लेते हैं. सो व्हेन इलेक्ट्रॉन टेक्स द एनर्जी, इट जंप्स फ्रॉम लोअर एनर्जी शेल टू हायर एनर्जी शेल. At the same time, when the electron jumps from higher energy shell to lower energy shell, it loses energy. Electronic transition बोलता है. So जब electron transition होता है ना, जो energy lose or gained is in the form of radiation, that is given as delta E is equal to E2 minus E1. It is in the form of h nu or hc by lambda. आप nu भी कैलकुलेट कर सकते हैं, डेल्टा E by h और E2 minus E1 by h. h क्या है ऋचा शर्मा? h क्या से बोल सकते हैं हम? h का वैल्यू क्या है? h is called Planck's constant. इसका वैल्यू है, h का वैल्यू है 6.626 into 10 raise minus 34 joule second बेटा, right? Very good, nice. Okay, now one more important thing, whenever electron revolve around, फिर भी ये डायग्राम है, इसका जो फोर्स है ना, this is a tangential velocity, this is called centripetal force and this is called centrifugal force. Centripetal force is equal to centrifugal force, है ना. then only electrons stay there, right? क्लासिकल फिजिक्स का हिसाब से ये इलेक्ट्रॉन फॉलो करना जरूर कंडीशन है. राइट बेटा, एंड और एक रेडियस ऑफ हाइड्रोजन एटम भी कैलकुलेट किया गया. सो रेडियस ऑफ हाइड्रोजन एटम इज गिवन एज 0.529 into n square by z angstrom units and it is given as. इसका जो रेडियस डेरिवेशन करने के बाद दैट इज radius of nth orbit is n square h square upon 4 pi square m e square. So this is shell number, Planck's constant, 4 pi mass of electron, charge on electron. ठीक है. So you can say the electrons energy. Okay, so these boxes what I am maintaining is a cheat sheet, formula sheet बनाने का कोशिश करो. Right, Ishita, Abhinav, right? You are making cheat sheets now? Cheat sheets now? Right? Say, cheat sheet बनाने? हाँ, because making cheat sheets are very important in NEET examination. Before going for the exam, सारा के सारा टोटल टेक्स्ट बुक का जो जो टॉपिक्स के इसका पूरा के पूरा फॉर्मूला बना के एक बार रखना है. सो ये फार्मूला है इंपॉर्टेंट है, फार्मूला है इंपॉर्टेंट है, ये मेथड आप नीट क्लियर करने के इस्तेमाल करो बेटा. ठीक है. सो एनर्जी ई एन. सो एनर्जी हमेशा देखो नेगेटिव वैल्यू है. क्यों? सो इलेक्ट्रॉन इज रिवॉल्विंग अराउंड द न्यूक्लियस बाय द इन्फ्लुएंस ऑफ द न्यूक्लियस, राइट? सो व्हेन द इलेक्ट्रॉन इज एट रेस्ट, एनर्जी ऑफ द इलेक्ट्रॉन इज जीरो. इलेक्ट्रॉन का एनर्जी हमेशा जीरो होता है रेस्ट में. सो व्हेन इलेक्ट्रॉन खुद ही जा रहे हैं ना, सो इसका एनर्जी, काइनेटिक एनर्जी पॉजिटिव होता है. सो व्हेन द इलेक्ट्रॉन एटम में न्यूक्लियस के वजह से घूम रहे हैं ना, सो दैट इसका एनर्जी रेस्ट से कम होना, रेस्ट में जीरो है, रेस्ट से कम होना तो जीरो के कम होना नेगेटिव वैल्यू मिलेगा, है ना. सो दैट इट्स वैल्यू अलग अलग यूनिट में अलग अलग वैल्यूज दे दिया. सो ज्यादा से ज्यादा आपको ये वैल्यू काम आ जाएगा, ये वैल्यू काम आ जाएगा. ओके, सिंपली एटॉमिक नंबर और मास नंबर. सर प्लीज टेल इन इंग्लिश. यस, द विन आई विल डेफिनेटली टेल यू, definitely I'll tell you. Hold on a minute. Okay, so maximum we use this is a minus 13.6 by n square electron volt per atom, that is the energy of the electron, है ना, right? Anyways, as one of the student is asking, नाम क्या बेटा? Z is atomic number or mass number. So I mean to say atomic number is Z. Z is equal to number of protons. That's it. You can say number of electrons if the atom is neutral, or otherwise it is going to be number of protons. Atomic mass number this is A. That is the sum of proton number plus neutron number. So A is equal to Z plus N, right? Neutron number is equal to A minus Z. So I think you are clear with your doubt, beta, right? So my dear students, the win you written, what's your name? I want to know. I'm curious to know your name. Abhinav, सब ठीक लग रहे हैं? Okay, any understanding issues here? I think yes, that's good, very nice. Okay, right. Now talking about energy of the electron. When the electron is revolving around the nucleus, it has total energy. Total energy is the sum of kinetic energy plus potential energy. Kinetic energy is due to, thank you very much. Thank you very much. Are you love me? Very good, thank you. But you didn't say your name. You didn't say your name. Okay. So kinetic energy means energy due to movement. Potential energy means energy due to stability. So kinetic energy का kz e square by 2r and potential energy का minus kz e square by r. Total energy का minus kz e square by 2r. When you see this, काइनेटिक एनर्जी टोटल एनर्जी का मैग्नीट्यूड सेम है, लेकिन टोटल एनर्जी का नेगेटिव है, नेगेटिव क्वांटिटी। टोटल एनर्जी जो है ये वाला हमेशा है नेगेटिव क्वांटिटी, काइनेटिक एनर्जी पॉजिटिव क्वांटिटी, पोटेंशियल एनर्जी नेगेटिव क्वांटिटी, ख्याल में रखो, राइट। यसीन मीर, okay, I'm a first time dropper. I want to join in the batches where personal mentorship will be provided. Actually, there are so many courses, Ashir Mir, in Infinity Learn, where you're having a mastery teacher like me and a mentor, personal mentor भी है, doubt clarification sessions भी है, doubt apps भी है, periodic tests, weekly test, and paper discussions. An integrated program is available with Infinity Learn. If you want to join there, you can join in Infinity Learn. So in the description box, Infinity Learn app link is given. You can download it and you can use, okay, and you can get into the admitted there, right? So Tashwin, very good name, very good name. Daswin or Tashwin, okay, Tashwin, okay, for all subjects, Ashirmir, for all subjects, fine, right. If you want to join, you just get connected with me. In the next session, I am going to tell you the procedure for joining in any course. In the next session, if you want to know it, because that slide is not available with me, right, okay, right. So the potential energy is equal to times of the kinetic energy. Is it correct? Did I deny you that? क्योंकि ये वाला यहाँ पर पूरा दे दिया, total energy is equal to potential energy by 2 is equal to minus kinetic energy. So आपका हिसाब से potential energy is the total 2 into total energy है ना. So NEET करने के आपसे मिलने आऊँगा, okay, एड्रेस बता देना, हाँ पक्का अभिनव. So anyways, you can directly come to corporate office Infinity Learn at Hyderabad. We can meet at any time, okay, before NEET or after NEET or during NEET. So what's our choice आपका है, ठीक है मैडम, right. Anyways, so this एक ये वाला खतरनाक रिलेशन है, right. So जो भी एनर्जी आप कैलकुलेट किया पिछले वाला है, ये वाला टोटल एनर्जी का. सो इफ अगर टोटल एनर्जी दे देंगे तो पोटेंशियल एनर्जी उसमें आधा होगा. सो पोटेंशियल एनर्जी इज द ट्वाइस ऑफ टोटल एनर्जी. लेकिन काइनेटिक एनर्जी आप पॉजिटिव बोलना है, नेगेटिव लिखा हुआ. सो काइनेटिक एनर्जी ये नेगेटिव साइन इस तरफ आएंगे तो पॉजिटिव मिलेगा ना, क्योंकि ये चीज नेगेटिव चीज है. आर यू गेटिंग और नॉट? हाँ, डेफिनेटली तश्विन, ओके, नो प्रॉब्लम. इट्स ए इंग्लिश. सो बोथ इंग्लिश एंड हिंदी. So we are going to mix it according to, yeah, according to students' request we can discuss it. Not an issue, okay. You don't have to worry that teacher is teaching only in Hindi so that I don't understand. So here some students are from north here, so they understand if English and Hindi are mixed, right, okay. So we'll discuss the things in English as well as Hindi, fine. Is that fine? So if you find any kind of understanding in issues, you can just raise a simple statement, sir, English once more please, so that I can extremely available both in Hindi as well as English. Okay, right, fine, thumbs up. Good interaction, Yashir Mir and Tashwin. Is that fine? So talking about that the total energy is equal to potential energy. Yeah, potential energy by 2 is equal to kinetic energy. So let us see here, n is equal to 1, n is equal to 2, right. So here total energy is equal to minus 13.6, right. Here total energy is equal to how much? Energy is equal to minus 13.6 by n square. One low, this is a hydrogen atom, this is a nucleus, right? Yes, very good. Now it is n square, minus 13.6 by 2 square. So it is equal to minus 3.4 electron volt. So here it is equal to minus 3.4 electron volt, right? So if an electron want to jump from here to here, so what is the difference? ये दोनों shells में अंतर कितना है? So it is going to be 10.2 electron volt. This is what analysis is required. So I want to say, if an electron jumps from n is equal to 1 to n is equal to 1 to n is equal to 2, it has to absorb 10.2 electron volts. अगर एक इलेक्ट्रॉन यहाँ से नीचे आना कोशिश करते हैं, if an electron want to jump from n is equal to 2 to n is equal to 1, it should lose 10.2 electron volt. Hope you are understanding. Clear beta? Fine. So how much you have the kinetic energy? So the kinetic energy is going to be, so the kinetic energy, total energy, magnitude is same. So that it is going to be plus 13.6 electron volts plus 3.4 electron volt. है ना? फिर भी ये पोटेंशियल एनर्जी यहां पर कितना होगा? पोटेंशियल एनर्जी कितना होगा? That is minus 13.6 into 2. So potential energy is going to be minus 3.4 into 2. Right? So when electron jumps from here to here, potential and kinetic energy 13.6, change it to 3.4. So 10.2 electron volt kinetic energy decreased. Right? So here 2 into minus 10.2 electron volts potential energy is increased because the magnitude is negative. So the same logic you can use, this trick you can use in NEET examination. Mind it. So NEET crack करने के लिए आप कितना books पढ़ा है, how many hours you worked, how many books you read doesn't matter. How you taken the trick, that does matter. Hope you understand. Clear, Risha? That's great. That's great. Okay, let's talk about Bohr's atomic model. Derivation of Rydberg equation, we already did it. When an electron jumps from lower energy shell to higher energy shell, it gain energy. From higher energy shell to lower energy shell, it loses energy. And gain energy and the lose energy, the energy is in the form of radiation. A radiation का कुछ wave number होगा और wavelength होगा. ये calculate करने के लिए आपका पास ये equation है, आपका पास ये equation ये है, nu bar is equal to 1 by lambda is equal to pi square me to the power 4 upon ch cube of 1 by n1 square minus 1 by n2 square. Crystal clear, Abhinav? So ये जो चीज है सभी कांस्टेंट है. ओके, 2 पाई m e to the power, मास ऑफ इलेक्ट्रॉन कांस्टेंट है, इलेक्ट्रॉन चार्ज कांस्टेंट है. ओके Tashwin, hope you are understanding there, right? And light velocity constant, yeah, that's good. H Planck's constant is a constant. So kinetic energy to root to kinetic energy by mass to KEM velocity. Hi, yes. You said velocity is equal to root 2 Ke by m. That's not correct. Yeah, that's not correct. So I just want to say that is according to Broglie equation, root 2 KEM. Okay, that I am going to discuss. Wavelength is equal to root 2 K H by root 2 KEM. This is correct. Tashwin, according to de Broglie, not now, right? So that is according to the different version, right? I just want to make you correct over there. This is a constant and this constant is known as Rydberg constant. this is called, or that is called Rydberg constant. This is about Rydberg constant. Okay? Right. Fine. Tashwin, is that fine? So this value is 109681 centimeter or 6770, you can say. So I have a trick to understand this. Okay. Right. I have a trick in this. You just take this 109681 and simplify it. You are going to get approximate value is 1.1 into 10 to the power of 5 centimeter inverse, so that you can use this while you are doing numericals. Yes, or otherwise 1 by r is equal to 912 angstrom units. You can also use, this is the best. This is the best. Why? Because if you want to use this value, na, when you want to calculate wavelength, the entire value is going to be reversed, which gives a lot of calculation issues. So you can calculate angstrom into centimeters or meters. Okay, 1 angstrom unit is equal to 10 to the power of minus 8 centimeters. 1 angstrom unit is equal to 10 to the power of minus 10 meters. So Tashwin is on the way, he is in the fire. Okay, that's good. Every detail about the hydrogen spectrum, he got it, right? Fine. So Bohr also calculated the frequency. This is called frequency law. This what I want to say, wave number or wavelength, right? So this is about the frequency. In this frequency, you can use 3.29 into 10 rise 15 of 1 by n1 square minus 1 by n2 square second inverse or hertz. Okay, what is n1? To which shell the electron is coming when the electron is emitting energy. So during de-excitation, from which shell the electron is coming, that is what you call it as n2. So n1 and n2 decide what kind of spectral line it is. So for Lyman series, n1 is supposed to be 1, for Balmer series, n1 is supposed to be 2, and Paschen series 3, bracket series 4, Fun series 5. So सबसे ये spectral line में, so ultraviolet जो है Lyman and Balmer is visible and Paschen, bracket, Fun और infrared region में मिलेगा आपका, ठीक है, right? So calculation of the velocity. This is the calculation of velocity. Velocity of the electron around the nucleus is very fast. So it is almost equal to the velocity of light. That is calculated from quantization of angular momentum. So we know that quantization of angular momentum mvr is equal to nh by 2 pi. So that v is the velocity is equal to nh mh by 2 pi mr. That is your formula. So by putting all the values, you got it as 2.18 into 10 power 8 upon n. So I want to say electron value 2 power 8, 10 power 8 means 3 into 10 power 8, right? And here 2.18 into 10 power 8 centimeters per second. It is 100 kilometers variation as compared to the light velocity and the velocity of the light. Yes, it is Balmer visible, Lyman UV. Okay, so Paschen infrared, near infrared, okay, bracket middle infrared, and Paschen far infrared, Humphrey far infrared, right? That's good. So the explanation is given by Niels Bohr. You are on par, doing very good. And talking about number of revolutions per frequency, so the Paschen infrared, yes, that's good. So when the electron is revolving, how many revolutions it can make? The number of revolutions is 6.5 into 10 power 15 into z square by n cube. You can say So that is directly proportional to, for hydrogen atom, inversely proportional to n cube. So the time period of revolution, so how much time it takes for complete revolution, that is equal to 1.5 into 10 power minus 16 into n cube upon z square. So that is directly proportional to n cube. It is in seconds, right? So these are all important. Actually उसमें नीट में इतना डेप्थ नहीं चाहिए, लेकिन हाँ whenever you learn something ना थोड़ा सा इतना एज में होता है, सो एज में जाना इतना जरूरी है, so that we will be on topper. So whatever there in the syllabus you study, so on the syllabus there is an edge. So when you are on the edge, so there is a difference between a ranker and a topper, right? So hope you are all in the ranker series, right? I want to show you in the topper series as well. Okay, talking about explanation of hydrogen spectrum, we all did this. So when the electron is jumping from lower energy to higher energy and higher energy to lower energy, it loses energy. So that gives a spectrum. But the electron can directly come to the ground state or in several steps. When the electron is jumping from higher shell to lower shell, it may come directly or in several steps. So that एक ही electron hydrogen atom में इतना सारा स्पेक्ट्रल लाइन्स कैसे दे सकते हैं? सो डायरेक्ट इनडायरेक्ट स्टेप्स कॉम्बिनेशन में आपका मिलेगा इतना सारा इलेक्ट्रॉन spectral lines, so that if an electron jumping from n2 to n1 orbit, so maximum spectral lines is equal to n2 minus n1 of n2 minus n1 plus 1 upon 2. समझे बेटा? Clear? So let electron jumping from 6 to 1, कितने spectral lines आ सकते हैं? When the electron jumps from 6 to 1 ground state, how many maximum spectral lines that can be possible? May I know the answer? Come on, make it fast. Make it fast. So when the electron is coming 6 to 1, so that it is going to be 6 minus 1, 6 minus 1 plus 1 by 2. So that is going to be 6, 5 into 6 is equal to 15. 15. Spectral lines are coming. Samjhay? Are you getting or not? So Tashwin, come on. Any doubt? Tashwin, Richa, Ishita? Right. Abhinav? That's good. That's good. Fine, fine, fine. Okay. Now, explanation of hydrogen spectrum. So these are the advantages of the hydrogen spectrum. Bohr's model explains the stability of an atom, right? So Bohr's theory successfully explained atomic spectrum of hydrogen, and the theory explained the hydrogen spectrum, also the spectrum of helium 2 plus, lithium 2 plus. Yeah. Yes, Tashwin, actually in a week we are taking first 3 days 11th standard syllabus and next 3 days 12th standard syllabus. So Thursday, Friday, Saturday we will be discussing about the organic chemistry only. Okay. In organic chemistry we will be completing after finishing of physical chemistry and organic chemistry from NCERT. So tomorrow's topic is going to be periodic classification. Day after tomorrow is going to be chemical bonding. In one shot we are going to get lines of what we say all tricks and orders directly NEET only. So you can use directly yes, NCERT line by line we are extracting. So no one cannot explain NCERT line by line, sir, please, definitely. So when 10 lines are there in the NCERT, we are taking as 1 or 2 lines, as so all 10 lines together we make it as a 1 line and we present it and we explain it. So you don't have to worry about that. Hope you are understanding the concepts that I am giving. Tashwin, just give a thumbs up, an emoji, and a fiery emoji bhi dena. Tashwin, so I am explaining maximum in English. If Hindi comes na, you just ignore it. So you don't say, sir is using Hindi, so it is not my class, I will quit. No, 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 no. So you take English part and the other students take Hindi part. So give and take policy. Give and take policy, right? Just give a minute. So what are the disadvantages of Bohr's atomic theory? Ashwin, what are the disadvantages of? Yes, disadvantages in the Bohr's atomic theory एक काफी simple है. So he explains only one single electron species. Okay, he cannot explain the experimentally. This is one more advantage. The experimentally determined values. Bohr never did any experiment. He collected the experimental data from the other scientists, and he theoretically again he calculated. His theory is applied and calculated. So he got the value is exactly same, nearly same with the experimental value, which indicates his theory is correct. Got it? So he is a theoretical physics scientist. And talking about the value of Rydberg constant, again he got the same agreement. Rydberg is not a chemistry person, he is a mathematics. So he calculated the mathematical value of Rydberg constant value, is got good agreement with Bohr's atomic theory, right? So MVR is equal to NH by 2 pi is the best and only point that is given by Niels Bohr, and from there only he calculated energy, from there only he calculated velocity, from there only he calculated energy, radius and everything. Okay. Now, talking about limitations of Bohr's theory, Bohr's theory failed to explain the spectra of multi-electron atoms, multi-electron species, you can say. And this theory could not explain the fine spectrum. What is this fine spectrum? When the hydrogen spectra is taken, you got Lyman, Balmer, Paschen, Brackett, Fund series, right? So, if you see this particular spectral line under microscope, and you can see these spectral lines are elaborated and observes more spectral lines inside it. So that is called fine spectrum of hydrogen. So Bohr cannot explain this fine spectrum of hydrogen. Also, he cannot explain splitting of spectral lines in strong magnetic field, which is called Zeeman effect. Splitting of spectral line in strong electric field, that is called Stark effect. Stark effect and Zeeman effect explanation is not given by Niels Bohr. So that's about Bohr's atomic theory limitations. Bohr's atomic theory defines the exact projectile path actually, which is not related to wave nature. So what is wave nature? So we are going to learn after this slide. Okay, so his predictions are against to wave theory, and Bohr's theory is not an agreement with Heisenberg uncertainty principle. That is also we are going to see after these slides. So he could not explain the ability of atom to form molecules. He explained at the level of atoms. So atom molecule kaise banta hai? So the process is not explained by Niels Bohr, right? So now the ratio of radii of the first orbits of hydrogen, helium and lithium 2+. अरे कौन दे सकते हैं आंसर? तश्विन, अभिनव, ऋचा, ईशिता, हाँ, और कुछ देने वाला चाहता हो कि दे सकते हैं, हम भी खुश होता. हाँ, राइट. आंसर आप करना है, मैं कर रहा हूं. Electron revolve around the different orbitals of the nucleus. This is a part of Bohr's model. Yes, of course. You can say fixed orbitals. Different orbitals, it revolve depending upon the energy of it. So same electron can revolve here, depending upon the energy. Sometimes here, sometimes there, Spontaneously it won't happen, right? Okay, will you do the or you want me to do? Right, nice question you asked me. Yeah, Richa, you said D. 1:1:1. How it is 1:1:1? So radius of hydrogen-like species is directly is equal to n square by z into 0.529. So radius of hydrogen, radius of helium, radius of lithium 2 plus, right? So is directly proportional to the ratio of radii of the first orbit. So z is 1. So n square, 1 square, right? And 1 by 1 square you can say, right? It is 1, and 1 by 2, 1 by 3. So you cannot square here, right? Yes. So that is given as 1:1 by 2 is to 1 by 3. You multiply with this 6. If you multiply with this 6, you are going to get 6 is to 1 by 2 into 6 is equal to 3, and 1 by 3 into 6 is equal to 2. 6 is to 3 is to 2. 6 is to 3 is to 2. Option 3 is going to be the correct answer. Kani? Yeah, where you are? Kani? Okay, right. When the question comes now, students are coming. Students are coming with the question. Energy of electron in the orbits are quantized. Yes, their energy is fixed. That is called quantity is fixed. So it is called Tashwin. Energy of the electron in the orbits are always fixed. That is what you can say, quantized. Okay, fine. Right, you all understood? Richa Sharma, fine. We don't retract your message. Practice more questions. I will be regular, right? Definitely. If you like, definitely I will follow that only, right? Yes. Now, the ratio of wavelengths of the first line of Lyman series in the spectrum of hydrogen atom and the first line of the Balmer series of the spectrum of helium plus. Now, here hydrogen Lyman, first line in the Lyman, N1 is equal to 1. First line means N2 is equal to 2. And first line in the Balmer, this is the for hydrogen, Z is equal to 1. So 1 is given in the blue color, right, Richa? And here it is, I just want to come with a green color. For helium, Z is equal to 2, and the first line in the Balmer, Z is that is equal to N. N1 is equal to 2, N2 is equal to 3. Now you take these two ratios, ratio between blue and green, that's your answer. Who is going to give the answer? Give me the answer. You want me to give from my side? Right. Kani? Fine. Okay. So when you solve this, N1 and N2 for the Lyman series, you can see, my dear students, that's others. Where did you go? Okay. So N1 and 2, the first line of Lyman, 1 by lambda is equal to RZ square, 1 by 1 square, minus 1 by 2 square. So don't put R value, my dear students. Okay. So that is going to be RZ square upon of 3 by 4. So you can say 3 by 4, or that is 1 by lambda. For the Balmer series, I already mentioned N1 is equal to 2, N2 is equal to 3, right? 1 by lambda is equal to RZ square, 1 by 4 by 1 by 9. So it is going to be 5R by 36. So the ratio between these two with the wavelengths, 1 by lambda, 3R by 4 upon 5R by 36. If you take 3 by 4, 36 by 5, it is going to be 27 by 1. Instead of calculating and putting all the things in a line, I made a ready-made solution here. Hope you understand. 27 by 5, option 2 is getting the correct answer here. Option 2 here, Others given option B. That's correct. Kani, what about you? I'm expecting your answer. You have agreement with option 2. Others has given the correct answer. I appreciate. Others better. Good. Richa? Ishita kahan gaya? Where are you, Ishita? Okay. Any doubt in this? Right. Very good. We'll see one more. Right. An electronic transition in a hydrogen atom occurs from 6th level to 1st level, 1st excited state. 1st excited state. It's a trap. It's a trap. बच के तो रहना. Why? Because energy level 6th level to 1st excited state is given, not 1st state. 1st excited state means when the electron is jumping from here to here, you can see n is equal to 1, n is equal to 2, n is equal to 3. So n is equal to 1 is called ground state. This is what you call it, the 1st excited state. This is called 2nd excited state, right? So in the 1st excited state means n is equal to 2. So the number of spectral lines observed in Paschen series, you have to go in a manual way. Can you do it? Can you do it? आपका आंसर क्या होगा? जल्दी. N is equal to 4, n is equal to 5, like that. Okay. Anyways, you can say this is n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, n is equal to 6, है ना? So when the electron is jumping from n is equal to 6 to the 1st excited state, it can jump in this way. It can jump in this way. Okay, if it jump here, it is a Lyman. This is Balmer. This is Paschen. This is bracket, and this is fund. Okay, so it is coming like this to form the Paschen series. So it can come six to Paschen series means 3, right? Yes, you want to say, so that 6 minus 3, 6 minus 3 plus 1 by 2. So that is going to be 6 minus 3 is equal to 3. It is into, okay, and 6 minus 3 plus 1, 6 minus 2 is equal to 4 by 2, right? It is going to be 6. Answer D. Your answer. Okay, Kanya. Yes, very good. Answer is going to be D. So not 3. It is D. Right? You can say, you can directly it jump from here to here. So here to here. Okay. It can jump from here to here like this. Right? Okay. Anyways, if the shortest wavelength of hydrogen atom in the Lyman series is X, then the longest wavelength in Balmer series in He plus is. Who will do this? So it is the shortest wavelength in the Lyman series means shortest wavelength N2 is equal to infinity and N1 is equal to 1. Balmer series is N1 is equal to 1 and the longest N2 is equal to 2. Okay, clear? So you are going to take the value is X and you just take this value from this reference. So we have 1 by lambda is equal to rz square of 1 by n1 square minus 1 by n2 square. For Lyman series, n1 is equal to 1, lambda is equal to shortest if n2 is equal to infinity. For RH 1 by x is given, so that is 1 by lambda, so the hydrogen atom Z is equal to 1. For Balmer series, n1 is equal to 2 and lambda is equal to longest, n2 is equal to 3, that what I mentioned here. Okay, so Balmer series is going to be 2 and it is going to be 3, right beta? Very good. Now, so n1 is equal to 2, n2 is equal to 3, so lambda max is equal to 1 by, okay, 2 square of, this is for helium, 1 by 2 square minus 1 by 3 square, my dear students. So if we solve, so 1 by 4 minus 1 by 9, so 5 by 36 is equal to 9x by 5 is going to be the answer. Right here, 9x upon 5, option 1 is the correct answer for this, right? Yes, of course, Kanya, we can do this. You can do this, right beta? Right beta? Okay, we'll go back to this once again. We'll go back to this once again. My dear students, I want to take back the answer that is given by me. So it is asked maximum spectral lines that is formed in the Paschen series. So for the Paschen series, you can see, I just want to take back my answer. N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4, N is equal to 5, N is equal to 6. If the electron is jumping to here, it is called Lyman series, Balmer series, Paschen series, and it is asked how many Paschen series lines can be formed when electron is coming from 6th level to first excited state. So it is coming to 6th level, maximum 1 it can be made, okay, that is not right, and this it can come, and from here it can come, here it can come, from here it can come, right? In this, the Paschen line spectra are going to be here 1, here 2, and here it is 3. So I just want to go with the 3 only. Can you just see one retraction in my answer? So answer is going to be 3. Read the question once again. You understand this? You understand this? Clear? Your option is wrong and this is the correct option. Even when I solved it before, I ignored Paschen series. I have given the 4th option like you, but it is option 3 is the correct answer. I want to correct myself, right? Now, talking about the first ionization energy of hydrogen atom is E, and the first ionization energy of helium would be, actually I just want to say the amount of energy that required to remove the electron from the atom is called ionization energy from isolated gases, neutral atom, periodic table, right? So yes, that's what I want to say. Even I did the same mistake there. So my dear students, is a trap actually. In this trap, I just want to show the variation how a student goes in the wrong way. However, the student is a good student and sincere student and well studied student, right? Here I just want to say ionization energy. So ionization energy is equal to plus energy of nth electron is equal to plus 13.6 by n square into z square, right? So if we use this logic, you can say ionization energy is energy z square upon n square, that is equal to 0. So when the electron is removed completely out of the atom and is kept outside the atom, its energy is considered as electron's energy is 0. So उसी समय में इलेक्ट्रॉन का एनर्जी 0 होगा. सो ये इलेक्ट्रॉन निकालने के एनर्जी कितना होगा? सो जितने एनर्जी है माइनस है उतना प्लस दे दो, इसका एनर्जी 0 होगा ना. So energy of the electron inside the atom is minus. If you give the same magnitude of the plus, its energy is going to be 0, right? So based on this, for hydrogen atom, Z is equal to 1, ionization energy is equal to E. So I just want to say that is plus 13.6. Okay. So for helium, Z is equal to 2. For the first ionization, the value of the N is equal to 1. Ionization energy is equal to Ez square. So that is equal to E into 2 square, that is 4E. Where is this? Option 4 is the correct answer. Got it? Got it? That's good. That's good. Fourth option, right? So you study the Bohr's atomic theory. These are the models of the question you are going to see in the NEET examination, my dear students. Okay, let it be any kind of competitive examinations. This is the way. This is the version you need to, right? So the ratio of energy of electron in the ground state. So you see the models, the clarity, and you see the previous year questions from the NEET examination or previous AIPMT. So you are going to get DC models only. I am lacking the formula of atomic structure. Yes, definitely we can have. You want me to send it privately? Join in Telegram channel. There's total. I want to send a cheat sheet in the private channel, not in what you say Telegram channel. You join in the Telegram channel, Kanyamudan. So Telegram, yes, send all, everything I'll send it. Okay. So join in the Telegram channel, and in the chat box also you can see the Google Forms there, right? Gia edits. Hi. Oh, different names are given, right? Okay. Okay, who will do this? Who will do this? Fatafat, make it fast. Will you do, or you want me to do? Will you do, or you want me to do? Okay. Right. We will do. So, how much time? Richa, Ishita, come on. Where are you? Abhinav, where are you? Come on. So I want to see in the chat box, Richa, Abhinav, Ishita, where are you? Come on. So without you, how can I conduct class? Come on, come on. Josh kahan hai class mein? Right. Yes. You see, energy is given as minus 13.6 into Z square by N square, right? Oh, you got it. Very good. Very good. Congratulations, Kanya. Congratulations. Okay, so energy of hydrogen, energy of beryllium 3 plus is equal to 1 by 4 square by 4. So that is 1 by 4. 1:4. ठीक है? Clear? Right. Use trick only you use it. Who asked you to solve the entire questions, huh? Okay. Richa Sharma, where are you? Hope you understood this. Ishita, Abhinav unknown. Right. So talking about de Broglie concept. De Broglie concept says electron revolve around the nucleus in a circular path according to Bohr. That's good. According to Bohr. Whereas Broglie, de Broglie or de Broglie, okay, it's not de Broglie. That's a wrong pronunciation. He's from Germany. De Broglie said not circle. So electron revolve just like a wave, right? So he said dual behavior. Any particle has both particle nature as well as a wave nature, and the wavelength is directly proportional to its momentum. So that is given as, this is called de Broglie equation. So lambda is inversely proportional to mass into velocity. Okay. So lambda is equal to h by mv. H is equal to Planck's constant. Yeah, so whatsoever you are preparing for G or BITSAT doesn't matter, the same concepts only, right beta? So let's go ahead. So here let's talk de Broglie equation from the Einstein. De Broglie said both particle as well as a wave, that is what you call dual behavior, that is called dual behavior. So according to Einstein generalization, E is equal to hc by lambda. Okay, so from Einstein mass energy relation is equal to E is equal to mc square. So hc by lambda and mc square I just want to equate. On rearranging, lambda is equal to h by mc. You can also say lambda is equal to h by mass into velocity. Light velocity and fast moving particle are similarly related, right beta? So this is what you call it as de Broglie wave equation. So the waves associated with the material particles are known as matter waves or particle waves, and the wavelength of a particle motion is inversely proportional to the momentum. That's what we discussed. Okay, de Broglie concept and the Bohr's theory. So that is what you say, lambda is directly proportional to mv. Lambda is equal to h by mv. Okay, lambda is equal to h by p, where p is equal to mass into velocity, right? Okay, de Broglie concept and Bohr's theory. Bohr said angular momentum is quantized. Mvr is equal to nh by 2 pi. He calculated energy, radiation and velocity, everything based on Mvr is equal to nh by 2 pi. But Bohr failed to explain why Mvr is equal to nh by 2 pi. But de Broglie explained that. Okay beta? So he said two types of waves are possible for an electron moving around the nucleus in circular path. One is standing circular non-energy radiating and non-stationary energy radiating. I mean to say here, yes, he want to say this is the nucleus, an electron revolve around the nucleus in a circular path like this. So in a circular wave like path, in this circle you can see the wave is like this. So it is a stationary wave in phase. And one more possibility is second one. In the second one you can see it is like this. So it is non-phase, it is in the phase, and this kind of interface is necessary. So thank you. Okay, not an issue here. 2 pi r is equal to n lambda. Lambda is equal to 2 pi r by n, right? So according to Broglie, lambda is equal to h by mv. H by mv. So you take these two equations and equate it. What will happen, children? So 2 pi r by n is equal to h by mv. So on rearranging, mvr is equal to nh by 2 pi. Again angular momentum is quantized. So that is what you call it as de Broglie and Bohr's concept, right beta? Right. So let's go ahead. That's what it is said. Yes. So it is necessary condition to get an electron wave in a phase that the circumference of the Bohr's orbit is equal to integral such that 2 pi r is equal to n lambda. So lambda is equal to 2 pi r by n. That is the essential condition, where de Broglie wavelength of a moving particle, lambda is equal to h by root 2 k E m or 2 m E. E is equal to kinetic energy, right? So, Kani, you are asking about this only, right? So, lambda is equal to h by root 2 m q v. So, q is the charge and v is the accelerating potential. When a charged particle is getting accelerated, its kinetic energy and the wavelength are related like this. Lambda is equal to h by root 2 qvm. That's very important. So it can be calculated with electron as well with a lot of calculation issues. I have a simple trick for the electron. For electron, lambda is equal to 12.27 into root accelerating potential. V is equal to accelerating potential. So this is important in the NEET examination, right? So this is how it is derived. I have a derivation also. So that derivation you don't need it. If you put all the constant values, you are going to get lambda is equal to 12.27 into root accelerating potential. Okay, fine, that's good. And you have for the proton, previous one, it is all about electron. It is lambda is equal to 12.27 into root voltage. For the proton, wavelength is equal to root 0.286 by root accelerating potential. For alpha particle, for deuterium, this is the one. And for alpha particle 0.1 into root accelerating potential, right? So from here you are going to get very good number of questions. And so calculate the ratio of the de Broglie wavelength for the proton and alpha particle if their kinetic energies are the same. This is the kind of questions that you are going to get in the NEET examination for you, right? Yes. Simran, hi. Can you do or you want me to do? Aap karna hai? मैं करूं. Kani, you can do. Richa, I think you can do it. Ishita, you are also. What about Abhinav? So this you can do. Calculate the ratio of de Broglie wavelength for the proton and alpha particle if their kinetic energies are same, right? Okay, I am going to do this. No issues. Fine, better, right? Okay, let's go ahead. So many questions we need to do. So lambda is equal to h by root 2 KEM. So that is lambda given kinetic energies are same. So wavelength of proton is equal to h by root 2 mass of the proton kinetic energy. Okay. So mass of alpha particle wavelength is equal to h upon root 2 4 mass of proton and Ke because mass of alpha particle is equal to 4 times the mass of the proton, right? That's fine. Okay. So that if you take these two ratios term, so you can take it up as a square over there, so that you can say you can strike h over there, and kinetic energy you can strike it, mass of proton you can strike it. Okay. So that you are going to get, yes, root 4 is going to be left. Root 4 is equal to here to 2 by 1 is the answer. So like this you are going to get a question. Fine, that's good. Fine. Very good, nice. So this is very important model of the question. You just have to practice all these models, right? And Heisenberg uncertainty principle. So Heisenberg uncertainty principle, he is actually foot holding step for classical structure of atom and the modern structure of atom, right? So you can improve your NEET score. A link is given in the Google Forms. You all check that link so that you just get the updates of about all the curriculum, how it is going on, and everything you are going to get into that, right? So that data is important. So however you study, however you study well, you need a proper mentor, you need a proper driving force for your journey. For that, we are already given an Instagram link also. You join in that so that you will be upgrading yourself in your NEET preparation, my dear students. ठीक है, चलो. So Heisenberg uncertainty principle said, अरे electron is revolving around the nucleus in a particular definite path. यहाँ पर इलेक्ट्रॉन होगा. सो आपको कैसे पता चलेगा इलेक्ट्रॉन ऐसे रहने के लिए? सो इट इज इम्पॉसिबल टू से द एग्जैक्ट पोजीशन एंड द मोमेंटम ऑफ द इलेक्ट्रॉन accurately and simultaneously. That is what Heisenberg uncertainty principle said. अरे अगर आप कैलकुलेट करने को नहीं, आप ये लाइट इस्तेमाल करने का कोशिश करना. So when light is allowed to fall on the electron absorb the energy, इसका जगह बदल रहे. So its place is changing, right? So when its place is changing, its momentum अलग होता है, its position is also say different, right? So that it is impossible to measure the exact position and the momentum of the electron simultaneously and accurately. That's the reason why if you want to do, you are going to get error. कितने error मिल रहे? So infinite error you are going to get. That's what it is given. The uncertainty in the position is delta x, uncertainty in the momentum is delta p. It should be greater than h by n pi. So n can be 1, 2, 3, 4. Okay, you can say h by n pi, any value it can take it. So significance of uncertainty principle, that's very important. Yeah, that's very good. So uncertainty principle ruled out existence of definite path of trajectories of electrons under similar particles. हमारा ये जो डिस्कशन आज का स्ट्रक्चर ऑफ एटम में इलेक्ट्रॉन का ही होगा. ओके, सो द principle significant only for the motion of microscopic objects like electron, proton, any moving subatomic particles, and is negligible for that macro particles like aeroplane, rocket kind of things. In dealing with milligram size or heavier objects, the associated uncertainties are hardly of any real consequences. So it is only applicable for electron like species. Okay? So talking about hydrogen molecule and the helium atom are moving with the same velocity, then the ratio of their de Broglie wavelength. Jaldi, a question. Simran, right? Kani? Yes, my dear students, you are really enjoying the lectures. So you like and just hit the like button and you just share with your friends also, they can enjoy. You are only enjoying, not only you, let your friends be enjoyed. And by the way, you also subscribe to this channel so that every day you join the session so that you can clear NEET examination without any fail. Okay, इसका आंसर क्या होगा? नहीं? Okay, रीचा कहाँ गए तो? Where are you? रीचा शर्मा, Ishita. Yes, the answer comes to be like this is, yeah. So hydrogen molecule and helium atom are moving with the same velocity, then the ratio of the de Broglie wavelength is, so lambda is equal to h by mass into velocity. Lambda is inversely proportional to mass. So lambda of hydrogen and helium is equal to mass of helium and mass of hydrogen. Mass of helium is 4 and 1. So that it is going to be so lambda is equal to h by mv. So hydrogen means H2 helium means this one. So lambda is inversely proportional to mass. So lambda of hydrogen, lambda of helium, right, is equal to mass of helium and mass of hydrogen. Mass of helium is 4 by 2 is equal to 2. Answer 1 is the correct answer, right? Simran, clear? That's fine, that's fine. नहीं. Hydrogen atom नहीं घूमेगा ना, hydrogen molecule घूमना चाहिए, right? Okay. Simran, were you there in the previous class? Okay. That's we can do it. Now, which of the following is responsible to rule out? Okay. Which of the following responsible to rule out the existence of definite path of trajectories of electron? I think you can say. That you can say. Simple you can say. That is about Heisenberg uncertainty principle only. Because it says the electron existence, you cannot directly predict it, because existence means two things are required. One is position and another one is momentum. These two things cannot be predicted accurately and simultaneously. Okay, so here, yes, for an electron to have the same de Broglie wavelength as the deuteron, okay, its velocity should be x times that of a deuteron. So deuteron, what is deuteron here, right? Yes, that's what is Heisenberg only. Yeah, that's correct. Right. Here it is, lambda is equal to h by mv, so that this is the formula. H by mass of electron, velocity of electron, of h by mass of deuterium, h of deuterium, right? This is the ratio. So if they have the same, okay, so velocity of electron, velocity of deuteron is equal to mass of deuteron is the mass of electron. So that mass of deuteron is equal to 3.343 into 10 power minus 27 kg, and mass of electron is 9.1 into 10 power minus 31 kg. So that velocity on solving 3.3, 9.1 ये manipulate करके, so it is coming to be 3674 is coming the answer. So approximate करके ये आंसर निकलना. Simple. You simply take the ratio so that you will understand. ठीक है? Right. If uncertainty in position and velocity are equal, so this is a very important equation. This is asked many times in NEET as well as in IITs, right? Okay. So what is the exact answer? If the uncertainty in position and velocity are equal, the uncertainty in momentum will be, so we are coming to the end of the session where, yeah. Okay, so simple answer, if uncertainty in the position is equal to uncertainty in the velocity, so that you can say uncertainty in position and momentum is greater than h by 4 pi, right? If this delta x and delta mv, right, so is equal to h by 4 pi, given condition is this, so according to this condition, you can say delta x m delta v, so it is going to be the same, so delta mv square is equal to h by 4 pi m, right, h by 4 pi m. So if that is the case, delta p is equal to m into delta v is equal to m into root h by 4 pi m. Simple, this is your answer. So that you are going to get root m h by 4 pi. So 4 is coming out, so that 1 by 2 ban gaya. So that delta p is going to be 1 by 2 root m h by pi. So that is your answer. So answer is going to be A. This is a very important model that you can already seen this model in previous year question from the various competitive examinations, my dear students. Clear beta? So today we discussed about the Bohr's atomic theory, total we recapped once. After that we discussed about de Broglie and we did a good number of questions, Simran. Okay, after that Heisenberg uncertainty principle, along with that we already discussed some previous year questions also, my dear students. In tomorrow's class I just want to discuss about previous year questions, right? We will be discussing about periodic classification in one shot, and we will be having quantum mechanical model after this, Schrodinger wave equation, Hund's rule, and the Pauli's exclusion principle, Aufbau rule, electronic configuration, shapes of orbitals, node, nodal plane, everything we are going to discuss in that platform. Okay, I think that comes on the next Monday, and tomorrow get ready with your one shot in the periodic table. So hope you enjoyed and do much number of questions. Please like our session and share with your friends and subscribe, and you please join in this Telegram channel that is presented in the chat box, and also fill your Google Forms link that is being given, my dear students. So thank you very much for the great session with a lot of enthusiasm and fiery emojis, and I'm signing off. Suresh Avari from Infinity Land by Sri Chaitanya. Thank you very much.